Okay, Assalamualaikum dan selamat pagi. Kita masuk tajuk terakhir dalam differentiation iaitu parametric differentiation. Okay, learning outcome at the end of this lesson, students should be able to solve the first and the second parametric derivative. Menyelesaikan persamaan pertama dan kedua bagi parametric derivative. First derivative of parametric equation. If we have two functions, x in terms of t and y also in terms of t, we call a parametric equation. With t, we call a parameter. We can find the derivative if we differentiate parametric equation using the chain rule. dy dx equal to dy dt times dt dx. Okay, example 1. Find dy dx in terms of parametric t if x equal to 2t cubed and y equal to 4t squared plus 1. First, we find dx dt. X equal to 2t cubed. If we differentiate respect to t, we get dx dt 2 times 3, 6, and then the power of t reduced to 1. So that means 6t square. But we must find dt dx. dt dx. So kita hanya terbalikkan saja. dt dx equal to 1 over 6t square. Lepas tu kita cari dy dt. Y equal to 4t square plus 1. dy dt equal to 4, 2 times 4, 8, and then t power of 1. The power of t reduced 1. So dy dx equal to dy dt times dt dx. dy dt equal to 8t, and then dt dx equal to 1 over 6t square. Okay, the final answer 4 over 3t. Example 2. Find dy dx in terms of parameter t if x equal to 5 sin t and y equal to 2t plus cos t. X equal to 5 sin 2t. So dx dt equal to, if we differentiate sign, you get cos. This is cos. So phi is a phi, actually is a phi is a remain phi, and then differentiate sign, you get cos 2t, and then differentiate 2t, we get 2. So 5 times 2, so we get 10. 10 cos 2t. Therefore, dt dx equal to 1 over 10 cos 2t. Y equal 2t plus cos t. Differentiate y respect to t. So dy dt equal 2. And then differentiate cos, we get a negative sin t. Therefore, dy dx equal to dy dt, and then times dt dx. Dy dt equal to 2 minus sine t times dt dx equal to 1 over 10 cos 2t. So this is the final answer. Example 3. Find dy dx in terms of parameter t equal to x equal to 1 over t squared plus 2t and y equal to 4t squared minus 1 over t cubed. First we find dx dt. So dx dt equal to negative 2 t power of negative 3 plus 2. So write as a single fraction 2t cubed minus 2 over t cubed. Therefore, dt dx equal to t cubed over 2t cubed minus 2. Okay, second, find dy dt. Y equal to 4t squared minus 1 over 3t cubed. So equal to 4t squared minus 1 over 3 t power of negative 3. So differentiate y respect to t. So we get 8t plus t power of negative 4. Or we can write as 8t plus 1 over t power of 4 as a single fraction xt power of 5 plus 1 over t power of 4. So dy dx equal to dy dt times dt dx. Dy dx equal to dy dt is 8t power 5 plus 1 over t power 4 times dt dx equal to t cubed over 2t cubed minus 2. So we can cancel t power of here, t power of 3, we can cancel here. So we get 8t power 5 plus 1. And then t times 2t power of 3, 2t power of 4 minus 2t. Or we can factorize to t, 8t power 5 plus 1 over 2t, t power of 3 minus 1. Okay, example 4, find dy dx in terms of parameter t if x equal 3 over t and y equal to square root 1 plus t square. Okay, x equal 3 over t, that means we can write as a 3t power of negative 1. So dx dt equal to negative 3t power of negative 2. Or we can write as a negative 3 over t square. Okay, therefore dt dx equal to negative t square over 3. Okay, y equal to square root 1 plus t square. Okay, we can write as a 1 plus t square power of half. So dy dt equal to the half, you time with half here. And then 1 plus t square remain. The power of 1 plus t square reduce 1. So we get negative 1 over 2. And then differentiate 1 plus t square, we get a 2t. So 2 here we can cancel. So we get a t 1 plus t square of negative 1 over 2. Or here we can write this is equal to, actually this is we can write as a t over square root 1 plus t square. Okay, dy dx equal to dy dt times dt dx. Okay, so after we simplify, we get negative 3 cubed over 3 square root 1 plus t square. Okay, example 5. Find dy dx in terms of parameter t if x equal to t minus ln 2t and y equal to t square minus ln t square. Okay, first we find dx dt. So dx dt equal to minus 2 over 2t. So we can cancel 2 here. So we get 2 minus 1 over t, right, as a single fraction, 2t minus 1 over t. Therefore, dt dx equal t over 2t minus 1. Okay, y equal to t square minus ln t, right, as a simplest form, t square minus 2 ln t. So dy dt equal to t minus 2 over t. Okay, as a single fraction, 2t square minus 2 over t. Therefore, dy dx equal to dy dt times dt dx. Okay, dy dt equal to t square minus 2 over t, and then times dt dx t over 2t minus 1. So we can cancel t and t. So we get answer 2t square minus 2 over 2t minus 1. Okay, next example, example 6. Find dy dx in terms of parameter t if x equal to negative cos 3t and y equal to 2 sine square 3t. Okay, find dx dt. X equal to negative 3 cos 3t. Okay, so to differentiate x respect to t, okay, this is a negative, actually negative. The differentiate cos, we get a negative sine 3t. Differentiate 3t, we get 3. So we can write negative is positive 3 sine 3t. So therefore dt dx equal to 1 over 3 sine 3t. Okay, y equal 2 sine square 3t. So dy dt, we get a 2, the power of sine here. 2 times 2, we get a 4. Remain sine t 3t. And then after that, differentiate sine 3t, we get a cos 3t. After that, differentiate sine differentiate 3t, we get 3. So 3 and 4 we can times, so we get a 12 sine 3t cos 3t. Okay, so dy dx equal to dy dt times dt dx. Dy dt equal to 12 sine 3t cos 3t times 1 over 3 sine 3t. So we can cancel sine 3t here. This is sine 3t. This is a 1. This is a 4. So the final solution, we get a 4 cos 3t. Okay, example 7. Find the value of dy dx if x equal t minus 1 over t and y equal to t plus 4 over t when t equal to. So first of all, we find dx dt. Okay, so dx dt equal to 1 plus t power of negative 2, or dx dt equal to t square plus 1 over t square. Therefore, dt dx equal t square over t square plus 1. Next, y equal to t plus 4 over t. So we can write as a 2t plus 4t of negative 1. So therefore, dy dt equal to minus negative minus 4 t of negative 2. Or we can write as a 2 minus 4 over t square, or 2t square minus 4 over t square. Therefore, dy dx equal to dy dt times dt dx. Dy dt equal to t square minus 4 over t square times dt dx equal t square over t square plus 1. So t square with t square we can cancel. So we get the answer 2t square minus 4 over t square plus 1. The question is, what is the value for dy dx when t equal to? So when t equal to, dy dx equal to 4 over 5. You just substitute t equal to into a dy dx. Okay, we go to the second derivative of parametric equation. Okay, so we have a dy dx in term of t, dy dx in term of t, and then to find the second derivative, this is a second derivative. So we apply a change rules again because dy dx in term of parameter t. Okay, so this is the formula to find the second derivative for the parametric equation. So that's mean here differentiate again dy dx respect to t. Differentiate dy dx respect to t, and then you time dt dx. Okay, actually this is we can write as a d second derivative dt. Here it is a dt dx. So and then ada dx. So cancel. So kita dapat di second derivative. Okay. So example 8. Given x equal 2 over 1 minus t square and y equal t over 1 minus t, show that dy dx equal to 1 over 4 1 minus t. So we find dx dt. So x equal to times 1 minus t power of negative 2. and then find dx dt. So dx dt equal to negative 2 times 2. So negative 4. 1 minus t remain. And then the power is reduced 1. So we get negative 3. After that, differentiate inside the bracket, get negative 1. So we get a 4 over 1 minus t power of 3. So therefore, dt dx equal to 1 minus t cubed over 4. Okay, next find dy dt. Okay, y equal to t over 1 minus t. This is related as a u, this is related as a v, and then we use a quotient rule. Okay, this is a quotient rule. This is a v times u prime minus, and then u v prime over v square. So v equal to 1 minus t, u prime is 1, minus u is equal to t, and then v prime equal to negative 1 over 1 minus t, and then u square. This is a quotient rule. Okay, next 1 and then minus t plus t, that means cancel, you get 1 only. So 1 minus t square. This is a dy dt. So dy dx equal to dy dt times dt dx. Dy dx equal to dy dt ialah, this is dy dt. 1 over, this is dy dt. 1 over 1 minus t square. And then dt dx, this is dt dx, 1 minus t cubed over 4. So we can cancel here, we can simplify. So we get a 1 over 4, 1 minus t, and then tertunjuk. Okay, B, find the second derivative. Okay, for the second derivative, we differentiate dy dx in terms of t. Differentiate again dy dx in terms of t. Okay, this is a dy. This is a dy dx. You differentiate respect to t. And then this is a dt dx from the previous solution. So differentiate 1 over 4, 1 minus t, you get a negative 1 over 4. Because this is a 1 over 4 minus 1 over 4t. Yeah? This is 1 over 4 minus 1 over 4t. Differentiate 1 over 4 is 0. Differentiate negative 1 over 4t, you get a negative 1 over 4. So 1 minus 3, 1 minus x power of 3, and then over 4. So that means the answer is negative 16, 1 minus t cubed. Okay, example 9. Find the first and the second derivative. If x equal to 1 plus t times e power of 2t and y equal to 4 exponent 2t. Okay, this is a, we let it u, this is a v, because this is a product here. We use for find the x dt, we use a product rule. Okay, we use a product rule. This is a u, this is a v, this is a u, this is a u v prime, this is a v prime plus u prime v. Okay, u equal to 1 plus t, v prime equal to e, differentiate e power of 2t, we get a 2 e power of 2t. And then u prime equal to 1, and then this is a v e power of 2t. So we can simplify, get a 3 e power of 2t plus 2t e power of 2t. Okay, therefore dt dx equal to 1 over 3 e power of 2t plus 2t e power of 2t. Okay, and then y equal to 4 e power of 2t. So dy dt equal to 8 e power of 2t. Okay, next, this dx dt, this is a dy dt. Next, we find dy dx. Dy dx equal to dy dt times dt dx. Okay, dy dt equal to 8 e power of 2t. And then dt dx equal to 1 over 3 e power of 2t plus 2t e power of 2t. Actually, we can cancel e power of 2t. Okay, we can cancel e power of 2t. So we get 8 over 3 plus 2t. This is a dy dx. Okay, this is a dy dx. Okay, next, to find the second derivative, we differentiate again dy dx in terms of t. Okay, differentiate dy dx respect to t. Okay, we can write it as 8 times 3 plus 2t of negative 1. So we can times negative 1 with 8 here. Negative 8, 3 plus 2t remain. And then the power is reduced 1, negative 2, differentiate inside the bracket, we get 2. And then this is a dt, this is a dt dx. Okay, after we simplify, we get a negative 8 times 2, negative 16, 3 plus 2t, negative 2 over 3 plus 2t. Actually, this is equal to 3 plus 2t power of 3. Okay, this is a second derivative. Okay, example 10, find the first and second derivative. If x equal to 1 over t and y equal to 3t squared plus 2. Okay, dx dt equal to negative 1 over t squared. And then, therefore, dt dx equal to negative t squared. Okay, next, y equal to 3t squared plus 2, therefore dy dt equal to 60. So this is a dt dx, this is a dy dt. Therefore, dy dx equal to dy dt times dt dx. So dy dt equal to 60. And then dt dx equal to negative t squared. So the answer dy dx equal to negative t power of 3. So the second derivative, differentiate dy dx respect to t, and then you time with dt dx. So differentiate negative 60 cube, get a negative 18t square, and then this dt dx. So the answer equal to 18 t power of 4. This is a second derivative. Okay, example 11. Find dy dx and second derivative when t equals 0, if x equal t e power of 2t, and then y equal to e power of 2t. Okay, x equal t times e power of 2t, so let this is a u, and then this is a v, using the product rule. So remain u, differentiate e power of 2t, we get 2 e power of 2t, plus differentiate t, get 1, and then remain e power of 2t. So we can write as a 2t plus 1 e power of 2t. This is a dx dt, therefore dt dx equal to 1 over 2t plus 1 times e power of 2t. This is a dt dx. And then y equal to e power of 2t, dy dt equal to 2 e power of 2t. So dy dx equal to dy dt times dt dx. So dy dt equal 2 e power of 2t. Okay, this is a dy dt. dt dx equal to 1 over 2t plus 1 e power of 2t. So we can cancel e power of 2t. So we get a 2 over 2t plus 1. This is dy dx. When t equals 0, you substitute t equal to 0, we get a dy dx equal to. Okay, next I'll find the second derivative. Second derivative, differentiate again dy dx in terms of t, and then you time with dt dx. Okay, differentiate dy. This is a dy dx. So 2 over 2t plus 1, I write as a 2 times 2t plus 1 power of negative 1. So negative 2 times negative 1 times 2, so you get a negative 2t plus 1 power of negative 2, differentiate inside the bracket equal 2. And then after we simplify, you get a negative 4 over 2t plus 1 power of 3 e power of 2t. So when t equal to 0, we get a second derivative equal to negative 4. 1 power of 3 is 1, e power of 0 is 1. That means negative 4 over 1 is negative 4. Okay, that's all for today. Thank you. Oke, code kuliah hari ini adalah RBO 05. Code kuliah hari ini adalah RBO 05. Oke, thank you. Bye-bye.